so let's talk now about equivalencies in predicate logic. And, again, these are two sentences that are logically equivalent, even though they might look quite different. And we would prove this by showing that one sentence can be derived from the other and vice versa, of course, using the predicate deduction system. The way that we would show two sentences to be not equivalent is by building an interpretation where one of them is true and the other one is not, which I think we already practiced a few units ago. Okay, so let's take a look at these. These look like two things that should be logically equivalent, right? For all x, not fx, in other words, everything is not f, and this says there is no x such that x is f. In other words, there's nothing that's f, right? So those sound, all x are, everything's not f, nothing is f. Those sound equivalent, right? So let's go ahead and see if we can get a proof. All right. So the first direction of our proof will go from all x not fx to nothing is f. Okay, so this is an assumption. We get some assumptions to work with this time. So how are we going to get this? Well, we're going to have to make an assumption this again and start a subderivation, because there's no direct way from here to here. Okay, using universal elimination is not really going to get us anywhere yet. Okay, so we're going to have to assume the negation of what we're trying to get here. Okay, and this is an assumption for purposes of negation introduction. All right, so what are we trying to get in this subderivation? We're trying to get some kind of a contradiction, right? And this is one of those kind of odd ones where the contradiction that we're going to try to get, we're going to try to get a contradiction with this, and it's going to be, so we're going to try to derive this inside of this subderivation. And, it kind of makes you wonder, why didn't we just do that in the first place out here? It's because we need this extra premise in order to get this. Okay, so we need to do it in this subderivation first to show that this is a contradiction. Okay, so how do we proceed here? Well, we're going to have to use existential elimination, which, like I said, is kind of the touchiest one. But we know we need to use it because this is we need this so we can get a contradiction with this, right? Because this definitely looks like a contradiction. We're saying something is f, but everything is not f. But we need to go ahead and get this quantifier off in order to use this. So we have to pick a constant that's new to the proof. That's no problem. Okay, there's no constants in the proof yet. So you just use a. Okay, so that's an assumption for purposes of existential elimination. All right. So what are we trying to derive in here? Let's so we can't, whatever it is, it can't have the letter a in it. So why don't we see if we can get this inside of here, and then we can take it out using existential elimination. Okay? So how might we go about getting this? Well, again, we're going to do it by negation introduction. Okay, so this is a pattern that we've seen before. It's that kind of odd one where sometimes you have to assume something you already have. Okay, so we're assuming something. We're assuming this because we're going to show that there's we actually already pretty much have a contradiction here because we have FA here, We can get not FA from this anytime we want by using universal elimination, right, which is one of those rules that's pretty much unrestricted. And we're going to assume this so we can put this contradiction in here and then write this with the negation sign, right, by negation introduction. So this is an assumption for purposes of negation introduction, all right? Line, and again, that's a pattern that we've seen before where we want to derive we already have a contradiction and we need to get the negation of something, so we have to assume the opposite. We have to assume it in order to get the negated one. So we're just going to reiterate FA into here, okay? And then line 6 will be universal elimination on line 1 finally. Okay. All right. So we have our contradiction here. We can go ahead and close out this subderivation. And we have line 7 by negation introduction, lines 4 through 6. All right, so now we have line 8 by negation introduction, existential elimination, lines 3 through 7, lines 2 and then 3 through 7. Existential elimination. All right, so we took this existentially quantified sentence. We took the quantifier off and replaced the variable with a constant. All right, and we were able to derive this inside of the subderivation. So now we can close this off and get this out, right? Because we met all the restrictions on using existential elimination. We used a new letter, and that letter was not in the formula, the sentence that we took out of this subderivation. All right, and now we're done with this proof, okay? It was a short but kind of complicated one. And from lines 2 through 8 and negation introduction, we have this. All right, and now let's turn this around and take it the other way. For the last proof, you guys will have to watch me do in this course, okay? All right, so this one's a little different, all right, because it's tempting to start trying to do this by negation elimination. And maybe you could get a proof like that, but there's a more direct way to do this, right? We're going to use the rule of universal introduction, which can be that can also be kind of a touchy rule to use, but we'll make sure that we follow the restrictions to do it, right? Because this is saying that nothing is F. And so it should follow that, it should follow that everything is not F, all right? So we'll see if we can just prove that directly. All right, so suppose that we just assume there's this thing, FA, for purposes of negation introduction. And it should be clear that we're going to get a contradiction in here because this says, our starting assumption is that nothing is F, and we're assuming that there's this thing A that's F. All right, so we're going to do this. We're going to use one of the easy rules, existential introduction on line 2. All right, and now we're going to reiterate line 1 into there. So we have a contradiction here, And we can go ahead now and we know not FA because FA got us right into a contradiction. Okay. 2 through 4, negation introduction. All right, now notice A is not, it's not present, this constant A is not present in any open assumptions, right? It's present here, but we closed this assumption off. So it's almost like we were reasoning about some generic thing. We said, suppose there's some generic thing, let's just call it A, and say A is F and see where that gets us, and it got us into a contradiction. So this generic thing must not be F, and because it's generic, we can assume that whatever we got there, it holds for everything, right? In other words, we can use universal introduction on it, and that's it. We're done with our proof. And we're allowed to do that because A is not present in any open assumption, and it's not present in this conclusion that we're getting.